ladies and gentlemen, our next exciting speaker of the day is Nikolai Mukin. Nikolai Mukin is a software engineer at Yandex, and he joined us yesterday. He flew in from Serbia, and we are so happy to have him here. Like many of you in this room, in your day-to-day lives, you are coders, just like Nikolai. And Nikolai is a coder today who will share with us how to improve your applications through observability. My apologies. Please join me in welcoming to the stage Nikolai Mukin. Welcome to stage.
Oh, the clicker. Sorry. Okay, hello guys. My name is Nikolai Mukin. I'm a software engineer at Yandex. And to be honest, I'm more used for talking to the code, not to actual people like you. Well, so today I'm going to talk about distributed tracing with open telemetry. The talk is going to be split in two parts. The first one is about distributed tracing concept and introduction to open telemetry project. The second one is about is an example of an application instrumentation in Go. So the first part could be interesting for like variety of IT specialists, but the second one probably is going to be interested mostly for developers and engineers. Okay, let's begin. So distributed tracing is a part of a broader topic of observability. The more observable the system is, the better engineers understand how it works. Why is it important? So let's consider an example that a new release introduced an untested bug that slipped into production system. The system is not working properly and end users are affected. So the business is losing money, and the faster engineers figure out the problem and fix it, the better. So this is an extreme example, but overall, observability, like the ability to understand how the system behaves, is essential for engineering. Okay. The term observability has several definitions. One of them is that observability is the ability to understand the inner state of the system given its outputs. Another one, that observability is a technical solution that allows teams to debug their systems. Okay, so in order to be observable, a system must output some information about its internal state. This information usually comes in form of logs, traces, and metrics. Those three are often referred to as three pillars of observability. Logs are just generic statements about events happening in the system. Metrics measure system-specific properties, while traces give request-specific insights. So let's focus on tracing. Tracing allows us to track the flow of the request through the system. So it gives us the understanding how the request is being processed, as well as timings of different operations. Tracing is called distributed if the request flows through a distributed system. Tracing could be very useful in a number of situations, such as developing a new application, writing a new microservice, for example, or figuring out dependencies between services, or figuring out the network usage of those services. Another case is addressing long-tail latency, or just fixing the problem, like locating the issue in state of emergency. Distributed tracing is most valuable for distributed environments, like tracing is most valuable for distributed environments, but complex systems can benefit from it as well. Okay. So when an application finishes to serve the request, related data needs to go to the tracing system. There are a lot of tracing systems available out there. The most popular ones are Uber's Jaeger and Twitter, Zipkin, and those are open sourced. So the most popular open source ones are Jaeger and Zipkin. And there are a lot of commercial solutions on the market. Most of those systems were designed after Dapr, a Google large-scale tracing infrastructure. So the paper about Dapr described a protocol that many vendors adopted, but different vendors implemented that protocol in different ways. So that it was difficult for customers to change vendors because of those implementation details. To address that issue, open standards were created. The most noticeable ones are open tracing and open census. Open tracing focused on tracing, provided standard protocol and API specifications. Open census, on the other hand, worked with traces and metrics as well, and focused on instrumentation libraries and the pipeline, the delivery pipeline to the tracing backend. But overall, both projects were solving the same issue, but okay. So both projects were solving the same issue, but with different ways, different passes. And that led to some uncertainty, like which project to use. Because of that uncertainty, it was decided that it is going to be better for two projects to merge into one, which came by the name of Open Telemetry, which we are going to discuss today. So, Open Telemetry is a cloud-native computing foundation project. It is currently in incubating stage. It is the second fastest growing project based on submitted commits. The first one is, of course, Kubernetes. OpenTelemetry provides layers for creating telemetry, like producing telemetry and collecting it. OpenTelemetry is not focused only on tracing, but works with different types of telemetry. Currently, logs, traces, and metrics are supported. But there is a proposition for continuous profiling support as well. The project provides open standards and specifications to how to create telemetry data, collect it, and process to the tracing backends. Also, OpenTelemetry gives specifications for the APIs that can be used to instrument common libraries and frameworks without vendor locking. Also, the project provides language-specific SDKs that implement those APIs. OpenTelemetry has a rich ecosystem of instrumentation libraries and frameworks already. A lot of them are contributed by open source community. And last but not least, OpenTelemetry provides an hotel collector. This is an application that is used to process telemetry data and deliver it to tracing backends. Processing consists of aggregation, sampling, filtering, and enrichment of telemetry data. So overall, the project provides you with everything everything you need to create telemetry data and deliver it to the tracing backends. But it is not, or any telemetry data backends, but it is not a backend itself. Okay, so now let's look at tracing specification in OpenTelemetry project. So, a trace is a direct acyclic graph of spans. Span represents a unit of work. So spans are basically the type of data that is created in applications and is being sent to tracing system. Span has a state. State consists of operation name, start and finish timestamp, some attributes, event logs, links to other spans, links to other spans. Also, a span has a parent span ID. This is needed to reconstruct the graph when all the spans come to the tracing system. Also, the span's state has a span context. Span context is an immutable piece of information that uniquely identifies as a span. And also, it is that piece of information that is required to propagate between the spans, so the parent-child relationship could be constructed. Well, span context consists of span ID, trace flags, and trace state. Trace flags currently hold only one flag that flags if a span is sampled or not. And trace state holds vendor-specific information. Span context is what is required to transfer between applications and inside applications in order to activate tracing. And that is pretty important, actually. So let's consider an example that there is an incoming request into the system that flows through the system. And in the middle of chain of calls, one service is not propagating span context. Then there is no information in downstream services to connect their spans to the original request. And tracing data will not be full. So be aware that in order to implement tracing, this is pretty important for all services and applications to propagate context between services and inside services as well. Okay, so how is span context propagated? Well, there is a protocol, the W3C protocol, for HTTP span context propagation. It describes how to propagate context in two headers. The first one, trace parent, holds all the identifiers and information that is required to identify the span. And the second one, trace state, holds vendor-specific data. Trace parent has 4 parts. The first one is protocol version, and currently only one version is available. The second part holds trace ID, and the third one, span ID. The last one holds trace flags. And trace state consists of vendor-specific data that is encoded in key value state. Okay, so now we know that in order to do tracing, our services need to create spans, send them to tracing system. Also, our services need to propagate span context in order to information to be full. Great. Let's look how it could be done. So in order to do that, we need to instrument an application, instrument our service. OpenTelemetry provides 2 ways to do it. The first one is automated. So it is available for languages like .NET, Java, JavaScript, PHP, and Python. Basically, there is a drop-in agent that modifies bytecode. So it modifies bytecode to instrument popular libraries and frameworks. And that is happening automatically. For compiled languages like Go, the instrumentation needs to be done manually. Okay. In order to do that, we need to follow the next steps. Import APIs and SDKs, configure those, create telemetry data, and export it to tracing system. Let's see how it's done. But first of all, let's return to the API specification. So we are interested in enabling 2 scenarios. The first one, creating spans and sending them to the tracing system. The second one, span context propagation. Sorry, start it again. The second one is to move span context between services. So, okay. For the first one, we need to work with the tracing API. Tracing API describes three entities. The first one being tracing provider. It holds all the configuration needed for delivery pipeline and is responsible for creating tracers. A tracer is an entity that provides spans, and span is a piece of information like a unit of work in the trace that we are interested in. Okay, now to the propagators API. In order to extract span context from incoming requests and inject it to the outgoing requests, we need to configure a propagator. Currently, only one type of propagators is available, text map propagator. Okay, great. Now, let's look at an example of a Go application, how to instrument it in order to produce spans and propagate context. We are going to look at the simple HTTP server application, simple HTTP server application. So the first step is to import APIs and SDKs. Done. The second one is to configure API. So here on the line numbers 16 and 17, we are configuring tracer provider and text map propagator. Great. Next step is to configure SDKs. In order to do that, we need an exporter. Exporter is responsible for sending our spans to the tracing backend. Here we are going to use an exporter that is using Open Telemetry protocol. Great. Next, we are going to create tracer provider. It takes an exporter and some configuration. Configuration is required to identify the service, an application that sends those spans. Cool. Next one is propagator. For the propagators, we are going to use composite propagator that consists of two propagators. The first one will use the standard OpenTelemetry context propagation using W3C protocol that we looked before. And the second one will use Jaeger protocol. We need it because we are expecting that some service is going to send requests with that protocol, and it is still not, it isn't instrumented with OpenTelemetry yet, but it will be soon, I hope. Great. So we configured our SDKs, and now we are ready to create telemetry data, create spans. Okay, in order to do that, we are going to use an instrumentation library. So how it's done? Let's suppose that our HTTP server is written using the package from the standard library, net HTTP. So there is a handler, and the server that is listening using that handler. So to create telemetry data, we will just use the instrumented equivalent of standard library, like that. So all we need to do is to wrap the original handler with the handler provided by Open Telemetry library. And, well, basically that's it. You have your instrumentation for your HTTP server, about 20 lines of code. Pretty easy, isn't it? So, yeah. But I wasn't, okay, sorry. But what I want to continue with is to dive deeper into the library itself and look at how it is implemented. So let's move in. First of all, the handler tests if request needs to be filtered. So it is useful to filter requests that you are not interested in. For example, health checks from orchestrator. Next, the context is extracted from the incoming headers, and some configuration options are specified. After a while, handler obtains a tracer to create the spans, and creates the required span. So the span is created on the line number 158, and the span end is deferred in line number the next line. After some manipulation with the body, the underlying handler is called. And after it finishes, some attributes are set to the span. So among others, there are attributes like body length for the request, body length for the response, and the HTTP status of the response. Well, if the underlying request ended with an error, then the span status will be set to an error as well. Okay. And well, that's basically how tracing, how OpenTelemetry library implements tracing. And if you are going to use this one as a bonus, you will get metrics implementations as well. So to use it, you will need to configure metrics API as well, and your server will provide such metrics as server latency, HTTP status codes, as well as lengths of bodies in the request and response. Okay, but what if your application doesn't use standard library? Well, the chances are, if you are using popular enough libraries, there already is an instrumentation for it. Here on the slide is an example for HTTP libraries for Go. And there are a lot of instrumentations for other languages as well. Okay, so we talked about concept of distributed tracing, OpenTelemetry project, and we looked at application instrumentation in Go. What we did not talk about is how the telemetry data should be collected and processed to the backend. There are some interesting challenges there, for example, tracing sampling. But that is a talk for another day, maybe for the next time. So thank you very much. I will be happy to answer your questions.
All right, thank you so much, Nikolai. Thank you, thank you, thank you. Ladies and gentlemen, our second to last Q&A period. Take a moment to scan the QR code and we will receive your questions. Nikolai, are you ready for your first question?
Yes.
Let's try it. Have you tried Grafana Stack that can collect all types of data, traces, logs, metrics, as a single solution? If yes, what are the disadvantages of it compared to separate tools?
Yeah, so to be honest, no, I haven't. Because I'm very inspired by OpenTelemetry project, like it is an open source initiative and cloud native computing foundation project. And I believe that the support of all open source community will drive this project further and further. So, yeah.
Thank you. How do you find the optimal balance between detailing of traces and performance? Detailing of traces, or we can go to this.
No, it's okay, I can handle it. Probably.
You can.
Yeah. So the question is how to balance between performance and delivery of traces, if I got it right. So for tracing, it is very common to sample a lot of traces because, like, because you don't need all that information that is coming like every second to your application. Let's imagine there is 1K RPS, and like in 10 minutes there will be a lot of traces already. So a lot of them are being dropped, and only a fraction is left, so you can figure out what's going with your application. And sampling is one of the tools how to balance with performance. So if you drop more traces, there is less traces to be delivered, and the system is more performant. So this is only one option. Others are data aggregation, filtering, and so on. So yep, you've got some options to tune in order to achieve what you want to achieve.
Thank you, Nikolai. Next question is, what tool can you recommend to visualize all the OTel data together? Metrics, logs, traces.
Yeah. So to be honest, I don't know. I haven't tried them all. And yeah, why I am not afraid to say that? Because like I was talking about open telemetry, and it is everything before the backends. And
Visualization, you got it, yes.
is apart from the backends. Yeah, so not sure there.
All right, and one last question for you. Have you ever tried to use eBPF to instrument compiled applications without recompiling them?
Well, that's a good question. No, I didn't.
Perfect, short and sweet.
Have you?
Nikolai, thank you so much for your time and for sharing your expertise. Did I hear something?
Thank you. Thank you very much.
Thank you for being here. Amazing.